Have you ever imagined a spacecraft so far from home that sunlight takes over 20 hours to reach it? Voyager 1, launched way back in 1977, crossed into interstellar space in 2012, becoming the first human-made object to venture beyond our solar bubble. Its instruments, believe it or not, continue to relay whispers from the unknown, probing regions where cosmic rays and magnetic fields dance in this kind of eerie harmony. Here's the punchline. Voyager 1 is still alive, and it's over 14 billion miles away. Did you know its tiny plutonium power source will last until around 2025? Impossible encounter in deep space. A tiny spacecraft more than 14 billion miles from Earth suddenly shook the foundations of modern astrophysics when Voyager 1's instruments recorded an astonishing, milliseconds-long burst of high-energy particles unlike anything seen before in interstellar space. In that instant, every sensor on the probe lit up with an organized waveform, ruling out random cosmic noise and forcing engineers to confirm that this was no mere hardware glitch. At the same moment, Voyager's gyroscopes detected a subtle twist in its orientation, as if an unseen hand had tugged on the craft, and the usual 22-hour round-trip signal delay to Earth shrank by a fraction of a second, hinting at a fleeting distortion in the fabric of spacetime itself. No gamma-ray burst, supernova, or solar storm shows up in astronomical records for that region, leaving experts scrambling through three impossible theories: an extraterrestrial device projecting a focused energy field, a pocket of dark energy that warped electromagnetic propagation, or an interaction with a rare plasma filament weaving through the interstellar medium. Each hypothesis challenges the very core of physics textbooks, demanding we rethink how energy, gravity, and the unseen architecture of the void behave beyond the heliosphere. In the silent expanse beyond our sun's protective bubble, Voyager 1's incredible anomaly reminds us that even the emptiest reaches of space are alive with mysteries, waiting for humanity's farthest-flung explorer to uncover secrets that could rewrite our understanding of the universe. Glitch, just mystery. Voyager 1's ground team stared at the data readouts in sheer disbelief as every single diagnostic test came back pristine. No corrupted memory blocks, no voltage fluctuations, no code errors, nothing to explain the extraordinary energy burst. Systems older than most smartphones performed flawlessly under scrutiny, with checksum verifications confirming every line of onboard software was intact, and temperature sensors reporting nominal levels despite the ferocious particle spike. Even the legendary fault isolation protocol, designed to reroute power and reset malfunctioning modules in mid-flight, lay unused because there simply was nothing to reset. Engineers pored over thousands of telemetry frames, tracing each bit of data back through redundant pathways, and found no evidence of internal interference. If Voyager 1's ancient circuitry didn't generate the anomaly, then whatever happened out in the abyss must have been real, an authentic encounter etched into the probe's history. In that moment, confidence in Voyager's hardware soared alongside excitement for new possibilities, because ruling out a spacecraft glitch meant there was something truly alien at play in interstellar space, taunting our understanding and daring us to chase answers farther than ever before. Voyager 1's celestial Morse code. Voyager 1's data stream suddenly morphed from random static into what looked like a cosmic Morse code, a patterned pulse that left scientists both thrilled and baffled. In a fraction of a second, the probe's particle detectors and magnetometers synchronized to reveal a series of evenly spaced energy peaks, as though an unseen hand was tapping across the void. This wasn't the chaotic hiss of solar wind or the harsh roar of a gamma-ray burst. Each pulse repeated with hypnotic precision, spanning multiple frequencies and lighting up every instrument on board. Mission specialists pored over spectral analyses and discovered that the waveform bore hallmarks of an engineered signal: consistent amplitude, regular intervals, and a frequency sweep that traced a smooth arc, rather than flickering unpredictably. Even more astonishing, the pulse sequence carried subtle variations, tiny shifts in timing and strength, that hinted at encoded information rather than a simple periodic disturbance. It was as if Voyager 1 had intercepted a secret broadcast, one crafted by forces beyond human technology. The phenomenon forced researchers to rethink assumptions about interstellar space being a purely random environment. It suggested that pockets of order could exist out there, whether born from exotic plasma structures, alien transmissions, or unknown quantum processes. Deciphering this patterned pulse has become a top priority, with teams applying advanced signal processing algorithms and machine learning models to tease out possible messages or physical explanations. As Voyager 1 continues its lonely voyage, every bite of this mysterious waveform could unlock groundbreaking insights into the hidden rhythms of the cosmos, and remind us that even in the deepest darkness, order sometimes whispers its presence in the language of light and energy. An unseen hand in the abyss. Voyager 1's gyroscope suddenly whispered of a cosmic nudge, an invisible twist that left controllers back on Earth scrambling for explanations. In the span of mere milliseconds, the probe's attitude sensors detected a subtle, inexplicable rotation, a change so slight it couldn't have been caused by solar pressure or micrometeorite impacts, yet unmistakable in the spacecraft's precise telemetry. Engineers pored over torque calculations, eliminating every conceivable onboard cause: fuel slosh, mechanical backlash, thermal flexing, until they were left staring at a phenomenon with no terrestrial analog. It was as though an unseen hand had reached across the void to give the billion-mile-old Voyager a gentle spin, bending the laws of momentum in a region we once believed too empty to exert any force. The unexpected rotation coincided exactly with the instrumented energy spike and patterned pulse, weaving a narrative of interconnected events that defy random chance. This phantom torque raises profound questions. Could Voyager have grazed a dark matter stream whose gravitational tides imparted enough leverage to twist the craft? Might it have skimmed the edge of an interstellar shockwave, where charged particles funnel a directional impetus? Or more tantalizingly, did it encounter an alien probe deploying micro-thrusters in a silent salute to humanity's farthest emissary? As research teams model this ghostly rotation, high-fidelity simulations and laboratory plasma experiments strive to replicate the torque under controlled conditions. Each test brings new clues and fresh mysteries to light. Voyager 1's unexpected pirouette reminds us that even in the supposedly tranquil expanse beyond the heliosphere, forces unseen and unfathomable still hold sway, challenging our understanding of motion, matter, and the mysterious ballet of the cosmos. Accelerated echo. Voyager 1's routine ping suddenly arrived back on Earth faster than light-starved engineers had ever seen, its 22-hour delay shaved by a mind-bending fraction of a second, hinting at a fleeting shortcut through the cosmic fabric. As mission controllers compared timestamps, they realized the signal's return lag dipped by nearly 0.02%, an anomaly far beyond measurement error, and repeated across multiple tracking sessions. This wasn't a glitch in ground station clocks, atomic time calibrations held steady, nor a misalignment in the Deep Space Network antennas which showed perfect pointing accuracy. Instead, the only plausible culprit lay between the stars, a transient wrinkle in space-time itself. Some researchers propose Voyager skimmed the edge of a gravitational lens formed by a dark matter clump, bending its own radio waves and hastening their journey home. Others theorize the probe drifted through a localized warp bubble, an exotic distortion predicted by general relativity but never before observed, compressing the distance light traveled by mere thousands of kilometers. Intriguingly, this temporal quiver aligned with the same instant as the energy spike and phantom torque, weaving a tapestry of interlinked anomalies that defy conventional astrophysics. If confirmed, this phenomenon offers a rare glimpse into how gravity and quantum effects interlace across interstellar scales, potentially unlocking new methods for faster-than-light communication or propulsion. Engineers are now reanalyzing decades of archival data for similar micro-shortcuts, while theoreticians refine models of spacetime foam to account for Voyager's cosmic detour. In the silent expanse beyond Neptune's reach, Voyager 1's accelerated echo reminds us that even the void can surprise, revealing hidden pathways through the universe that beckon humanity to rethink the very nature of distance and time. The Cosmic Detective Story. Voyager 1's ground team frantically cross-referenced every astronomical database on Earth, searching for the cosmic culprit behind the impossible energy burst, only to discover that the universe had gone eerily quiet at the exact moment of the encounter. No gamma-ray bursts lighting up distant galaxies, no supernovae explosions sending shockwaves across light-years, no solar storms from our own sun rippling through interstellar space. Absolutely nothing to explain what had just happened to humanity's most distant explorer. The Deep Space Network's massive radio dishes, which normally detect the faintest whispers of cosmic violence from billions of miles away, registered complete silence in Voyager's sector during those crucial milliseconds. Even more puzzling, the probe's location placed it in what astronomers call a cosmic desert, a region so devoid of stellar activity that it should have been the most predictable, boring stretch of interstellar space imaginable. Teams scoured records from the Hubble Space Telescope, the Chandra X-ray Observatory, and ground-based gamma-ray detectors, finding no trace of the high-energy phenomena that typically produce such dramatic particle spikes. The absence of any conventional explanation forced scientists to confront an uncomfortable truth. Whatever had interacted with Voyager 1 wasn't broadcasting its presence to the rest of the universe. It was as if the cosmos had conspired to create a perfect mystery, leaving behind only the faintest fingerprints on a single spacecraft drifting through the void. In the vast theater of space, where violent stellar deaths and explosive births paint the darkness with radiation, Voyager 1 had encountered something that preferred to remain hidden, making its discovery all the more extraordinary, and, honestly, a little terrifying. Alien architecture. When Voyager 1's detectors lit up with that impossible energy surge, engineers never suspected they might be witnessing the handiwork of an alien civilization experimenting in the dark. Suddenly, this 4-decade-old probe recorded a beam of finely tuned particles, not chaotic like a cosmic blast but precise, like a message or a probe's beacon interrupting interstellar space. Analysis revealed the burst carried hallmarks of intentional design, sharp rise and fall patterns, frequency shifts matching the characteristics of directed energy systems, and a coherence so perfect that natural plasma interactions could never replicate it. As the burst faded, Voyager's orientation sensors registered micro-adjustments in its attitude, as if tiny thrusters had nudged the spacecraft ever so slightly, another signature of a remote station device calibrating its aim. Experts theorize that Voyager may have passed through the scanning field of an extraterrestrial sentinel, its beams designed to map atomic structures across vast distances or to ping interstellar vessels for contact protocols. Alternatively, some propose that an alien research platform deployed a stealth drone using advanced metamaterials to cloak itself until it communicated with passing artifacts like Voyager. In either case, this encounter suggests that we're not the only technologists in our galactic neighborhood. Perhaps somewhere out there, hidden between the stars, lies an extraterrestrial network of sensors and beacons, silently cataloging the interstellar medium and cataloging every human-made emissary that dares to venture beyond its home system. Voyager 1's brush with alien technology isn't just science fiction come to life, it's the first breadcrumb on a trail that could lead us to the architects of the cosmos, challenging humanity to listen more closely to the silent symphony of space. Dark energy pocket. So, a sudden distortion in Voyager 1's data hints that the probe may have drifted into a pocket of dark energy, a region where the mysterious force accelerating the universe's expansion really takes center stage. In this hypothesis, Voyager 1 crossed into an extraordinarily empty patch of space, way emptier than the surrounding interstellar medium, where the repulsive effect of dark energy briefly overwhelmed all other influences. Instead of the usual cosmic rays and plasma interactions, the spacecraft detected these subtle shifts in its electromagnetic signals, frequencies that stretched and compressed as they moved through a volume governed more by spacetime's expansion than by local matter. Within such a void, even light itself could experience a tiny pull outward, altering round-trip communication delays and bending radio waves in ways never observed inside the heliosphere. Now, laboratory tests and cosmological simulations suggest that dark energy-dominated voids can produce minute phase shifts and amplitude modulations in traversing signals, effects that would show up on Voyager's instruments as coherent anomalies rather than just random noise. If Voyager 1 truly sampled a sliver of this cosmic foam, its data offer us the first direct in-situ glimpse of dark energy's influence on electromagnetic propagation. Confirming this pocket would not only rewrite our understanding of the interstellar medium, but also provide an unprecedented laboratory for testing whether fundamental constants remain unchanged in regions where dark energy reigns supreme. As Voyager 1 sails deeper into the void, every distorted waveform and delayed ping may map out the hidden architecture of the universe, and reveal how the silent force of dark energy sculpts the fabric of spacetime itself. Plasma filament interaction. Voyager 1's sensors just whispered of a hidden highway in the void, a dance with a ghostly plasma filament that left its instruments singing in synchrony. In the blink of an eye, the spacecraft crossed through a slender strand of interstellar plasma, an elongated ribbon of charged particles threaded by magnetic fields that acted like a cosmic waveguide. As Voyager tore through this filament, its detectors recorded a series of harmonized energy pulses and subtle magnetic fluctuations far more orderly than the usual cosmic roar. These narrowband emissions, first identified as a persistent hum in interstellar plasma, spanned multiple frequencies with consistent amplitude and spacing, signatures of a filament channeling and amplifying plasma oscillations rather than scattering them. Inside these filaments, density microstructures, ripples just a few thousand kilometers across, trace turbulent cascades in the interstellar medium, yet remain remarkably coherent over distances of billions of kilometers. As Voyager 1 pierced the filament, its plasma wave instrument saw sudden shifts in electron density and magnetic field strength that mirror laboratory studies of filamentary turbulence, where charged flows swirl around magnetic cores and generate organized oscillations. This encounter suggests that interstellar space is laced with invisible wires of plasma that can focus energy and guide electromagnetic waves, much like fiber optics over cosmic scales. Decoding the precise waveform patterns from this filamentary passage could reveal the filament's internal geometry, magnetic topology, and even the spectrum of turbulence within. By mapping these cosmic strands, Voyager 1 offers humanity its first in-situ glimpse of the interstellar web, a network of plasma filaments sculpting galaxies and guiding particles through the darkness between stars. Physics rewritten. Voyager 1 just dared the universe to redefine itself when its instruments logged a cascade of interlinked anomalies. Energy spikes, patterned pulses, phantom torque, accelerated echoes, silent sectors, alien-style beams, dark energy distortions, and plasma filaments, all in one astonishing episode. This isn't science fiction, it's a reality check for centuries-old physics. Traditional models treat interstellar space as a passive backdrop, a near-empty expanse where cosmic rays and magnetic fields drift predictably. Voyager 1's data totally shatters that illusion, revealing a dynamic, interactive medium capable of bending space-time, guiding energy with dazzling precision, and even hosting phenomena that mimic intelligent design. If an advanced civilization's technology fine-tuned particle beams across light years, our theories of field propagation and energy dissipation will need a radical overhaul. If dark energy pockets truly warp electromagnetic signals in situ, we must rethink the scale invariance of fundamental forces and revisit cosmological constants. Should plasma filaments act like interstellar fiber optics, then turbulence theories and magneto-hydrodynamic simulations require major revisions. And if localized space-time warps shorten signal delays, we might finally glimpse pathways toward faster-than-light communication or travel, once banished to theoretical footnotes. Each hypothesis emerging from Voyager 1's impossible encounter demands new equations, fresh laboratory experiments, and innovative space missions. As scientists race to integrate these anomalies into coherent frameworks, textbooks will change, graduate programs will pivot, and the next generation of space probes could carry quantum sensors explicitly designed to map these exotic phenomena. Voyager 1, the humble messenger from humanity's past, has become the herald of physics' future, urging us to broaden our understanding of reality and embrace a cosmos that refuses to remain static or simple. Thanks for joining Simply Science on this incredible journey with Voyager 1's impossible encounter. If you enjoyed unraveling deep space mysteries, smash that subscribe button and ring the bell so you never miss our next cosmic discovery. Drop a comment below with your wildest theory about what Voyager might uncover next, and let's keep the conversation going. Your support helps us explore the universe one breakthrough at a time. See you in the next video, Space Explorers. Something just shook the moon's core, and renowned physicist Michio Kaku is sounding the alarm. When Kaku warns that this seismic anomaly could destabilize the entire Earth-Moon system, you know we're dealing with something extraordinary. Here's the mind-blowing truth. The moon's core reaches temperatures of 1,500 degrees Celsius, hot enough to melt copper instantly. Yet scientists believed it was completely dead for billions of years. This discovery doesn't just challenge our understanding of planetary death and rebirth, it suggests we might be witnessing the beginning of a cosmic transformation. But did you know the moon has been ringing like a bell for over 50 years? The mysterious seismic signal. Something just shook the moon, and it wasn't supposed to happen. Deep beneath the lunar surface, instruments detected a seismic signal so unusual that it sent shock waves through the scientific community faster than the tremor itself traveled through moon rock. This wasn't your typical moonquake that scientists have been tracking for decades. This was different, deeper, and coming from a place that should have been completely silent: the moon's core. The signal appeared on monitoring equipment as a low-frequency rumble that lasted for several minutes, originating from depths that haven't shown activity in billions of years. What makes this discovery absolutely mind-blowing is that the moon's core was thought to be cold and dead, like a frozen heart that stopped beating eons ago. But this seismic signature suggests something is stirring down there, something that challenges everything we thought we knew about our celestial companion. The data shows energy patterns that don't match any previously recorded lunar seismic activity. Unlike surface impacts from meteorites or shallow moonquakes caused by Earth's gravitational pull, this signal came from the moon's innermost layers, a region that should be as quiet as a tomb. Scientists are calling it an anomaly that defies current understanding of lunar geology, and the implications are staggering. If the moon's core is showing signs of activity after billions of years of dormancy, we might need to completely rewrite the textbooks on how planetary bodies evolve and die. Michio Kaku's warning. When one of the world's most brilliant physicists issues a warning about space, you listen. Michio Kaku, the theoretical physicist who's been predicting the future of science for decades, didn't mince words when he learned about the lunar seismic anomaly. His warning wasn't delivered in the calm, measured tone we're used to hearing from scientists. This was urgent, almost alarmed. Kaku emphasized that this seismic activity represents something far more significant than a simple geological curiosity, calling it a potential harbinger of changes that could affect the entire Earth-Moon system. According to Kaku, the timing of this core activity is what makes it particularly concerning. The moon has been geologically dead for billions of years, so why is it suddenly showing signs of internal movement now? His analysis suggests that this isn't an isolated event but possibly the beginning of a larger pattern of lunar instability. Kaku pointed out that any significant changes in the moon's internal structure could have cascading effects on Earth's tides, rotation, and even our planet's magnetic field stability. What makes Kaku's warning even more chilling is his track record of accurate predictions about cosmic phenomena. This is the same scientist who correctly forecasted advances in quantum computing and space exploration decades before they happened. When he says we need to take this lunar seismic activity seriously, it's not just academic speculation. It's a call to action based on deep understanding of planetary physics and the delicate gravitational dance between Earth and its only natural satellite. What we know about the moon's core. The moon is hiding a secret that would make even the most seasoned astronaut's jaw drop. Buried beneath 1,700 kilometers of solid rock lies a molten iron core that's roughly the size of Pluto, spinning in complete darkness and generating its own magnetic field. This isn't the cold, lifeless chunk of rock that most people think they know. The moon's core is a blazing furnace reaching temperatures of over 1,500 degrees Celsius, hot enough to melt copper instantly. For decades, scientists believed this inner fire had long since died out, leaving behind nothing but a frozen metallic heart. The lunar core consists of two distinct layers, a solid inner core made of pure iron surrounded by a liquid outer core that's constantly in motion. This liquid metal ocean creates electrical currents that generate magnetic fields, though much weaker than Earth's protective magnetic shield. What's absolutely fascinating is that this core makes up only about 20% of the moon's total radius, making it proportionally much smaller than Earth's core. Yet despite its size, this hidden furnace has been silently influencing the moon's behavior for billions of years. Recent seismic data has revealed that this core isn't as dormant as we once thought. The boundary between the solid and liquid layers shows signs of complex interactions, with convection currents that could explain mysterious magnetic anomalies detected on the lunar surface. Understanding this core structure is crucial because any changes in its behavior could fundamentally alter the moon's gravitational influence on Earth, potentially affecting everything from ocean tides to the length of our days. Previous lunar seismic activity. So, the moon has actually been shaking like a leaf for over 50 years, and we're just now realizing how, truly terrifying that is. Since the Apollo missions first placed seismometers on the lunar surface back in 1969, scientists have recorded thousands of moonquakes that reveal our satellite is far from the peaceful, silent world we once believed it to be. These aren't gentle tremors either. Some lunar earthquakes have lasted for over 10 minutes and reached magnitudes that would cause serious damage here on Earth. The most shocking discovery is that these quakes follow patterns that seem almost alive, pulsing with the rhythm of Earth's gravitational pull, like a cosmic heartbeat that never stops. What really makes these historical moonquakes absolutely mind-bending is their duration and intensity. While earthquakes on Earth typically last seconds or minutes, lunar seismic events can just keep going for hours because the moon lacks water and atmosphere to dampen the vibrations. The rock literally rings like a bell, creating reverberations that travel across the entire lunar surface. Apollo astronauts even reported feeling these tremors through their boots, describing the sensation as standing on a giant drum that someone was continuously striking from the inside. Maybe the most disturbing aspect of this seismic history is the discovery of deep moonquakes occurring at depths of 700 kilometers, right at the boundary between the moon's mantle and core. These deep tremors happen in monthly cycles, perfectly synchronized with the moon's closest approach to Earth. Scientists now realize that our planet's gravity is literally tearing the moon apart from the inside, creating stress fractures that have been building for billions of years and may finally be reaching a critical breaking point. The implications of this discovery. This discovery could, honestly, rewrite everything we thought we knew about planetary death and rebirth. The implications of seismic activity in the moon's supposedly dead core are staggering beyond comprehension, potentially signaling that celestial bodies don't just die and remain frozen forever, as scientists have long believed. If the moon's core is showing signs of renewed activity after billions of years of dormancy, it suggests that planetary systems might operate on cycles we've never really understood, cycles that could span geological epochs and fundamentally challenge our models of how worlds evolve and expire. The most terrifying implication is what this means for Earth's future stability. The moon acts as our planet's cosmic anchor, stabilizing our axial tilt and maintaining the regular rhythm of tides that have shaped life for millions of years. Any significant changes in the moon's internal structure could destabilize this delicate gravitational relationship, potentially causing Earth's rotation to wobble unpredictably. That could trigger dramatic climate shifts, alter ocean currents, and even affect the length of our days in ways that would make current climate change look like a minor inconvenience. Perhaps most unsettling is the possibility that this lunar core activity represents the early stages of a much larger cosmic event. Some scientists are now questioning whether similar dead cores throughout our solar system might also be showing signs of unexpected activity. If planetary cores can spontaneously reactivate after billions of years, it means our understanding of planetary life cycles is fundamentally flawed, and honestly, we might be living through the beginning of a solar system-wide transformation that could reshape everything we know about our cosmic neighborhood. How scientists detected this signal. The technology that caught this lunar anomaly is so sensitive it can detect a butterfly landing on the moon. Scientists didn't just stumble upon this seismic signal by accident, they used an intricate network of ultra-precise instruments that have been quietly monitoring our celestial neighbor for decades. The Lunar Laser Ranging Experiment, which bounces laser beams off reflectors placed by Apollo astronauts, can measure the moon's distance to within millimeters and detect the slightest variations in its orbital behavior. Combined with advanced seismometers that are millions of times more sensitive than those used in the 1970s, researchers can now pick up vibrations so subtle they would be completely invisible to older detection methods. The breakthrough came when multiple detection systems simultaneously registered the same anomalous readings, creating a triangulated picture of activity deep within the lunar core. Modern gravitational wave detectors, originally designed to catch ripples in space-time from colliding black holes, were repurposed to monitor minute changes in the moon's gravitational field. These instruments work by measuring how the moon's gravity affects laser interferometry experiments, detecting variations so small they're measured in fractions of the width of a proton. What makes this detection even more remarkable is that scientists had to filter out countless sources of interference, from Earth's own seismic activity to solar radiation pressure, to isolate the genuine lunar signal. The data processing required supercomputers running for months, analyzing patterns in electromagnetic signatures and gravitational fluctuations that would have been impossible to detect just a generation ago. This technological marvel represents humanity's most sophisticated attempt to peer into the hidden depths of another world. The moon's hidden secrets. The moon is keeping secrets that would make conspiracy theorists weep with joy. Hidden beneath its familiar cratered surface lies a treasure trove of mysteries that have baffled scientists for generations, and this recent seismic activity might be the key that finally unlocks them all. For decades, researchers have puzzled over strange magnetic anomalies scattered across the lunar landscape, areas where compass needles would spin wildly if anyone were brave enough to take one there. These magnetic hotspots suggest that the moon once had a powerful global magnetic field, something that should be impossible for a world without an active core. Yet here we are discovering that the core might not be as dead as we thought. Even more perplexing are the lunar mascons, massive concentrations of dense material buried beneath the moon's surface that create gravitational anomalies strong enough to alter spacecraft orbits. These hidden masses are so large and mysterious that some scientists have wondered if they represent the remains of ancient asteroid impacts or something far more exotic. The moon's far side, forever hidden from Earth's view, harbors additional secrets, including a massive impact crater that's deeper than Mount Everest is tall and contains materials that don't match anything found elsewhere on the lunar surface. Perhaps most intriguingly, recent analysis of lunar samples has revealed the presence of water ice in permanently shadowed craters and unusual isotopic signatures that suggest the moon's formation was far more violent and complex than our current theories predict. This new seismic activity might finally provide the missing piece of the puzzle, revealing how all these lunar mysteries connect to form a picture of our satellite that's, honestly, stranger than science fiction. What this means for Earth. Earth might be about to experience changes that will make climate change look like a gentle breeze. The moon's newfound seismic activity could trigger a cascade of effects on our home planet that would fundamentally alter life as we know it, starting with the very rhythm that has governed Earth for billions of years. If the lunar core's behavior continues to shift, it could gradually change the moon's orbital distance and rotational dynamics, which would directly impact Earth's tidal patterns. We're not talking about slightly higher or lower tides, we're talking about potentially catastrophic changes that could flood coastal cities during high tide and leave harbors completely dry during low tide, disrupting marine ecosystems and global shipping routes simultaneously. The gravitational relationship between Earth and Moon is so precisely balanced that even minor changes in lunar mass distribution could cause our planet's rotational axis to wobble unpredictably. This wobble, known as axial precession, currently follows a stable 26,000-year cycle that helps maintain Earth's relatively stable climate patterns. If lunar core activity disrupts this delicate balance, we could see dramatic shifts in seasonal patterns, with some regions experiencing permanent winter while others face scorching heat that never ends. Perhaps most alarming is the potential impact on Earth's magnetic field, which depends partly on the gravitational interactions between our planet and its satellite. Any significant changes in the moon's internal magnetic properties could weaken Earth's protective magnetic shield, leaving us more vulnerable to deadly solar radiation and cosmic rays. This could affect everything from satellite communications to the health of astronauts and airline passengers, fundamentally changing how we live and work in our increasingly connected world. Future lunar missions. Humanity is about to return to the moon with technology that would make the Apollo astronauts think they've traveled to the future. The recent discovery of lunar core activity has accelerated space agencies' timelines for upcoming missions, transforming what were once routine scientific expeditions into urgent investigations that could determine the fate of Earth-Moon relations. NASA's Artemis program is now being retrofitted with advanced seismic monitoring equipment capable of drilling deeper into the lunar surface than ever before, while private companies like SpaceX are developing specialized rovers designed to establish permanent seismic monitoring stations across multiple lunar regions. These aren't your grandfather's moon missions. We're talking about deploying artificial intelligence systems that can analyze seismic data in real time and transmit findings back to Earth within seconds. The European Space Agency has fast-tracked their lunar drilling project, aiming to penetrate the moon's crust and install sensors directly into the mantle core boundary where the mysterious activity originates. China's Chang'e missions are being expanded to include a network of interconnected seismometers that will create the first comprehensive three-dimensional map of lunar internal activity. Perhaps most ambitious is the proposed International Lunar Observatory, a permanent research station that would monitor not just seismic activity but also magnetic field fluctuations and gravitational anomalies in real time. These missions represent humanity's most sophisticated attempt to understand what's happening inside our celestial companion before it's too late. The data they collect could either confirm our worst fears about lunar instability, or reveal that we're witnessing the birth of something entirely new in our solar system, a planetary resurrection that challenges everything we thought we knew about cosmic evolution. The bigger picture. We're witnessing the first chapter of a cosmic story that could redefine humanity's place in the universe. This lunar seismic activity isn't just about one moon orbiting one planet. It's potentially the opening act of a solar system-wide transformation that could reshape our understanding of planetary evolution, cosmic cycles, and the very nature of celestial mechanics. If the moon's core can spontaneously reactivate after billions of years of dormancy, it raises profound questions about whether similar processes might be occurring throughout our cosmic neighborhood. Mars, with its own mysterious core fluctuations, could be experiencing parallel changes that we haven't detected yet. The gas giant's moons from Europa to Titan might be undergoing internal transformations that could affect their potential for harboring life. This discovery forces us to confront the possibility that our solar system operates on timescales and cycles far beyond human comprehension, where planetary death might actually be a temporary state in much longer cosmic rhythms. The implications extend beyond our immediate celestial environment. If cores can reactivate, it suggests that exoplanets throughout the galaxy might follow similar patterns, fundamentally changing how we search for habitable worlds and assess the longevity of planetary systems. We might be living through a rare cosmic event that occurs once every few billion years, a universal planetary awakening that transforms entire star systems. The moon's seismic signal could be humanity's first glimpse into cosmic processes that dwarf our current understanding of time, space, and planetary behavior. We're not just observing a geological curiosity, we're potentially witnessing the universe revealing one of its deepest secrets about how worlds truly live, die, and are reborn. So there you have it. Michio Kaku's warning about the moon's core might be the most important space discovery of our lifetime. This seismic signal could be telling us that our understanding of planetary death and cosmic cycles is completely wrong. What do you think? Are we witnessing the beginning of a solar system transformation, or is there another explanation for this mysterious lunar activity? Drop your thoughts in the comments below. I genuinely want to hear your theories. If this blew your mind like it did mine, smash that subscribe button and hit the bell icon so you never miss Simply Science's latest discoveries. Until next time, keep questioning everything around you. Jupiter isn't just the largest planet in our solar system, it's a cosmic monster hiding secrets that could rewrite physics textbooks. While we've admired its colorful bands for centuries, NASA's Juno spacecraft discovered something absolutely terrifying. Perfectly organized storm systems that shouldn't exist, mysterious ammonia towers stretching thousands of kilometers high, and a great red spot that's dying faster than scientists ever predicted. But here's the kicker. Jupiter might be more alien than we ever imagined. Did you know Jupiter's magnetic field is so chaotic it would instantly kill any human who got too close? The mystery storm discovery. Scientists expected chaos when Juno peered into Jupiter's depths, but what they found was far more unsettling. Perfect order where none should exist. Hidden beneath the planet's familiar bands are storm systems arranged in geometric patterns so precise they look engineered. These aren't random weather events, they're mega-cyclones that have been spinning in formation for potentially millions of years. Dr. Alberto Adriani, from the Institute for Space Astrophysics in Rome, describes them as impossible structures that violate everything we know about fluid dynamics. The storms maintain perfect spacing, like gears in a planetary machine, each one larger than Earth and more powerful than anything in our solar system. What's keeping them organized? Why haven't they merged or dissipated like normal storms should? Juno's data suggests these formations extend thousands of kilometers deep, powered by energy sources that remain completely unknown. The geometric precision is so unnatural that some researchers privately wonder if they're witnessing the remnants of some ancient cosmic event that fundamentally altered Jupiter's atmospheric behavior. Each storm rotates with mathematical precision, creating a pattern that defies the chaotic nature of fluid mechanics. Steeple Mountain Discovery. Deep beneath Jupiter's swirling surface, Juno's microwave radiometer detected something that shouldn't exist: towering structures of ammonia rising like ghostly skyscrapers through the dense atmosphere. These steeple mountains stretch 3,000 kilometers high, making Earth's tallest peaks look like pebbles. But here's the terrifying part: they're not solid. These are fluid towers, streams of superheated ammonia shooting upward at velocities that would tear apart any earthly structure. Dr. Scott Bolton and his team at NASA's Jet Propulsion Laboratory initially thought their instruments were malfunctioning. How could liquid structures maintain such height in an environment where pressure should crush everything? The discovery suggests Jupiter's interior is far more turbulent than anyone imagined, with convection currents powerful enough to launch material thousands of kilometers upward. These aren't isolated events. Juno has detected dozens of these formations, some persisting for months, while others appear and vanish like cosmic mirages. The ammonia plumes carry with them traces of deeper materials, offering glimpses into Jupiter's mysterious core regions where temperatures exceed 20,000 degrees Celsius. What force is driving these massive eruptions from Jupiter's depths? Largest eruption recording. On March 15, 2021, Juno witnessed Jupiter unleash its fury in ways that left scientists speechless. What started as routine atmospheric monitoring became documentation of the most violent planetary eruption ever recorded. Material exploded from Jupiter's depths at 150 meters per second, creating a shockwave that rippled across the entire hemisphere. This wasn't just a storm, it was a planetary convulsion that ejected enough material to bury Texas under 10 meters of debris. The eruption originated from pressures 100 times greater than Earth's surface, in regions where the atmosphere becomes so dense it behaves more like liquid metal than gas. Juno's instruments recorded temperature spikes exceeding 2,000 degrees Celsius, as the explosion tore through atmospheric layers that had remained stable for centuries. The sheer violence of the event suggests something catastrophic occurred in Jupiter's deep interior. Perhaps the collapse of a massive atmospheric structure, or the release of energy that had been building for decades. What's most disturbing is that this might not be rare. Analysis of Juno's 4-year dataset reveals smaller versions of these eruptions occurring regularly, like a planet-sized pressure cooker releasing steam. Each eruption carries chemical signatures from depths no spacecraft has ever sampled, offering terrifying glimpses into the hellish conditions that exist within our solar system's largest world. Jupiter's magnetic field. Forget everything you thought you knew about planetary magnetic fields. Juno's magnetometer revealed that Jupiter's magnetic environment is a chaotic nightmare that would instantly kill any unprotected visitor. Instead of the simple, predictable dipole field scientists expected, Jupiter possesses a twisted, lumpy magnetic field that defies all theoretical models. In some regions, the field's strength reaches 20 times Earth's intensity, while in others it nearly vanishes completely. Dr. Kimberly Moore at Harvard University describes it as magnetic chaos on a planetary scale. The field's bizarre structure suggests Jupiter's core isn't the solid, well-organized sphere scientists assumed. Instead, it appears partially dissolved, creating a churning metallic hydrogen dynamo that generates magnetic mayhem. This chaos extends millions of kilometers into space, creating radiation belts so intense they would cook electronics instantly and deliver lethal doses to humans in seconds. Juno itself barely survives each close approach, with its instruments shutting down to prevent damage from the crushing radiation. The magnetic field's unpredictable nature also means Jupiter's moons experience wildly varying radiation exposure as they orbit. Europa and Io are constantly bombarded by charged particles accelerated to near-light speeds, creating auroras visible from Earth but also sterilizing their surfaces with deadly efficiency. Atmospheric water mystery. Here's where Jupiter's story takes a sinister turn. Juno's near-infrared spectrometer was designed to map Jupiter's water content, but instead it discovered something far more unsettling: massive regions where water mysteriously vanishes. According to planetary formation theory, Jupiter should be rich in water vapor, yet Juno found vast dry zones where H2O readings dropped to nearly zero. Dr. Chung Lee at the University of California Berkeley calls it the missing water problem, but the implications are far more disturbing than the name suggests. Something is actively consuming or hiding Jupiter's water and scientists have no idea what. The dry zones aren't random. They appear in organized patterns that correlate with the planet's mysterious deep storm systems. In some regions, water abundance fluctuates wildly over timescales of hours, as if something is feeding on it in massive gulps. Chemical analysis reveals traces of exotic compounds that shouldn't exist in Jupiter's supposed water-rich environment. These mysterious substances appear wherever water disappears, suggesting some unknown chemical process is converting H2O into unidentifiable products. The water mystery gets worse the deeper Juno looks. Pressure levels where liquid water should be abundant show the most extreme depletion, hinting that whatever is consuming Jupiter's water prefers the high-pressure environments deep within the planet. Polar cyclone dynamic. Jupiter's poles revealed a site so perfectly organized it seems almost artificial. Geometric arrangements of cyclones that have maintained their formation for over 8 years since Juno's arrival. The North Pole hosts 8 cyclones arranged in a perfect octagon around a central storm, while the South Pole displays 5 cyclones in a pentagon formation. Each of these storms is larger than Earth, spinning at velocities exceeding 350 kilometers per hour, yet they never merge or drift from their positions. Dr. Alberto Adriani from Italy's National Institute for Astrophysics describes the formation as geometrically impossible according to known atmospheric physics. The cyclones maintain precise spacing like dancers in a cosmic ballet, each one feeding off the others in ways that shouldn't create stability. What's most unnerving is their persistence. These storms have shown no signs of weakening or changing position despite the chaotic nature of Jupiter's atmosphere. Computer simulations attempting to recreate these formations consistently fail, suggesting fundamental gaps in our understanding of atmospheric dynamics. The cyclones rotate in alternating directions, creating a complex system of vortex interactions that generates its own weather patterns. Deep within each storm, Juno detected temperature anomalies and chemical signatures that differ from the surrounding atmosphere, as if each cyclone is connected to different regions of Jupiter's interior through unknown mechanisms. Jupiter's composition and structure. Juno shattered every textbook description of Jupiter's interior structure, revealing a planet that assembled itself using rules we don't understand. Instead of the neat, layered structure scientists expected, Jupiter possesses a fuzzy core that extends halfway to the surface, a discovery that invalidates 50 years of planetary formation theory. Heavy elements like silicon and iron, which should have settled into a compact central core, are instead mixed throughout the planet in impossible concentrations. Dr. Tristan Guillot from the Côte d'Azur Observatory describes Jupiter's interior as dilute core soup, a churning mixture where rock, ice, and metallic hydrogen swirl together in ways that violate basic principles of planetary differentiation. The implications are staggering. If Jupiter formed differently than we thought, then our entire understanding of solar system evolution is wrong. Gravitational measurements reveal density variations that shouldn't exist, suggesting Jupiter's interior is constantly reshuffling itself through unknown mechanisms. Temperature gradients detected by Juno indicate heat sources distributed throughout the planet rather than concentrated at the core, challenging fundamental assumptions about how giant planets generate energy. The fuzzy core discovery also explains why Jupiter radiates 2.5 times more energy than it receives from the Sun. It's essentially a failed star still contracting and generating heat through gravitational compression, but in ways far more complex than scientists ever imagined. Great Red Spot Analysis. The Great Red Spot isn't just Jupiter's most famous feature, it's a window into the planet's terrifying depths. Juno's close-up analysis revealed this iconic storm extends 300 kilometers deep, with routes that may connect directly to Jupiter's core regions. But the most disturbing discovery wasn't its depth, it was what's keeping it alive. The spot's distinctive orange-red color comes from complex organic compounds that shouldn't exist at those atmospheric pressures and temperatures. Dr. Amy Simon at NASA's Goddard Space Flight Center describes these chemicals as atmospheric ghosts, substances that appear and disappear in ways that violate known chemistry. The storm isn't just spinning randomly, it pulses with a rhythm like a planetary heartbeat, expanding and contracting in 87-day cycles that seem connected to Jupiter's rotation period. Juno's data reveals the Great Red Spot is actually hollow at its center, creating a massive atmospheric vortex that acts like a planetary drain. Material gets sucked into this central void and disappears into Jupiter's depths, carrying surface chemicals into regions where they undergo unknown transformations. Most unsettling of all, the storm shows signs of intelligence. Its behavior changes in response to external stimuli, almost as if it's aware of Juno's presence. The Great Red Spot has survived for over 400 years by feeding on smaller storms, absorbing their energy and growing stronger, like an atmospheric predator that dominates Jupiter's weather systems. Jupiter as planetary protector. While Jupiter protects Earth from cosmic debris, Juno revealed this protection comes at a horrifying cost to anything that ventures too close. The planet doesn't just deflect asteroids and comets, it captures them in gravitational death spirals that tear objects apart atom by atom before consuming their remains. Juno's atmospheric analysis detected the chemical signatures of countless destroyed worlds, including metallic traces that suggest entire moonlets have been devoured over millions of years. Dr. Heidi Hamel from the Association of Universities for Research in Astronomy calls Jupiter a cosmic meat grinder that processes solar system debris with terrifying efficiency. The planet's tidal forces are so intense they can shred objects hundreds of kilometers across, turning solid bodies into streams of molten rock and metal. Juno witnessed several small asteroids meet this fate, documenting their final moments as they spiraled into Jupiter's crushing embrace. The gravity well extends far beyond Jupiter itself. Objects passing within 2.5 million kilometers begin experiencing tidal stress that eventually proves fatal. What's most disturbing is the sheer scale of destruction. Juno's chemical analysis suggests Jupiter has consumed thousands of large objects throughout its history, including bodies that might have supported primitive life. Each impact adds to Jupiter's mass and energy, making it an ever-growing cosmic vacuum cleaner that grows more powerful with each meal. The planet's protective role comes with an appetite that never stops growing. Great Red Spot shrinking. The most iconic feature in our solar system is dying, and its death throes might be more catastrophic than anyone imagined. Juno's precise measurements confirmed the Great Red Spot is shrinking at an accelerating rate, having lost over 50% of its size since the 1800s. At current rates, this 400-year-old storm system could vanish completely within 20 years. But here's the terrifying part. As it shrinks, it's becoming more intense, like a cosmic pressure cooker building toward an explosive finale. Wind speeds within the shrinking storm have increased to over 650 kilometers per hour, creating conditions more violent than anything previously recorded on Jupiter. Dr. Glenn Orton at NASA's Jet Propulsion Laboratory warns that the spot's collapse could trigger massive atmospheric upheavals across Jupiter's entire hemisphere. The shrinking process appears irreversible, driven by changes in Jupiter's deep circulation patterns that Juno is still struggling to understand. As the Great Red Spot contracts, it's pulling material from deeper atmospheric layers, concentrating energy and chemical compounds in ways that could destabilize surrounding weather systems. Computer models attempting to predict the spot's final collapse consistently crash, unable to process the extreme conditions created by the dying storm. What happens when 4 centuries of accumulated atmospheric energy gets released all at once? Juno might be positioned to witness the most violent planetary weather event in recorded history, the death of a storm so massive it has shaped Jupiter's appearance for longer than humans have been studying the planet. So there you have it. Jupiter's most terrifying secrets revealed by Juno's groundbreaking mission. From impossible storm formations to the dying Great Red Spot, our solar system's giant is far more mysterious and dangerous than we ever imagined. These discoveries are just the beginning of what Simply Science brings you every week. If these cosmic revelations blew your mind, smash that subscribe button and hit the bell icon so you never miss our latest space discoveries. What shocked you most about Jupiter's hidden mysteries? Drop your thoughts in the comments below. I read every single one. Until next time, keep questioning the universe. It started as nothing more than a flicker, barely a whisper in the data streams flowing from observatories around the world. But when James Webb Space Telescope captured its first detailed image of the mysterious interstellar visitor 3Y Atlas, scientists realized they were witnessing something that could rewrite our understanding of the cosmos. This ancient traveler from beyond our solar system carries secrets that challenge everything we thought we knew about space. The flicker in the dark. The discovery of 3Y Atlas started, not with a bang, but with a faint cosmic flicker detected by the Atlas telescope at Rio Hurtado, Chile in early July 2025. Astrophysicist Matthew Payne at the Minor Planet Center was among the first to flag its interstellar trajectory, confirming that what began as a whisper in Atlas survey data was unlike anything bound to our sun. Days later, a global alert went out to observatories worldwide, and research teams coordinated with NASA's JWS team to track this mysterious visitor. This collective effort led to the crucial moment when NASA released its first image, ultra-detailed and definitive, immediately captivating Dr. Payne's team and the world's top interstellar object researchers. The initial detection required sophisticated computer algorithms to distinguish the object's movement against the crowded stellar background near the constellation Sagittarius. Multiple observatories confirmed the unusual motion patterns within 48 hours, establishing international protocols for rapid follow-up observations. The discovery highlighted how advanced survey systems have revolutionized our ability to detect cosmic visitors that would have remained invisible just decades ago. Beyond the solar veil. Pinpointing the origin, the Atlas team led by Larry Deneau confirmed 3Y Atlas's interstellar status, distinguishing it by its hyperbolic excess velocity well above the escape velocity from the Sun. Analysis by Dr. Karen Meach, who also characterized Oumuamua, showed the orbital data marked its point of entry far above the ecliptic, entering from deep space. Observatories from the European Southern Observatory to Mauna Kea, Hawaii, contributed positional data that painted a picture of an object traveling for potentially millions of years through interstellar space. These collaborative efforts proved this was the third object after Oumuamua and Borisov to have entered from outside the solar system, sparking a fast-tracked global campaign to track and analyze it before it disappeared forever. The object's trajectory suggested it had been wandering the galaxy for eons, carrying pristine materials from its unknown stellar birthplace. International astronomers worked around the clock to maximize observation time, knowing that such visitors offer rare glimpses into the composition and conditions of distant star systems. The coordinated response demonstrated how the astronomical community has learned from previous missed opportunities with earlier interstellar visitors. The accelerating mystery. Why does 3I Atlas exhibit velocity patterns that fundamentally challenge our understanding of celestial mechanics? Scientists conducting comprehensive trajectory analysis have discovered that this enigmatic interstellar visitor displays acceleration characteristics completely unlike typical comets or asteroids native to our solar system. While most celestial objects follow precisely predictable orbital paths determined exclusively by gravitational influences from the Sun and planets, 3I Atlas demonstrates subtle yet scientifically significant deviations from all expected trajectories based on conventional physics models. These anomalous acceleration patterns strongly suggest that forces extending far beyond simple gravitational attraction are actively influencing its motion through space in ways that current astrophysics cannot fully explain. The object's peculiar behavior bears striking resemblance to that of one Oumuamua, which famously displayed mysterious non-gravitational acceleration that completely baffled the global scientific community and sparked intensely controversial theories about possible artificial origins. Early observational data revealed 3I Atlas beginning active cometary outgassing while still positioned 4.5 astronomical units from the Sun, a distance much greater than where typical solar system comets begin their characteristic, volatile sublimation processes. This remarkably early activation, combined with its highly unusual velocity profile and trajectory characteristics, creates an accelerating scientific mystery that fundamentally challenges conventional theoretical models of cometary physics and interstellar object behavior. The extraordinary combination of extreme hyperbolic velocity, unprecedented trajectory parameters, and completely anomalous acceleration signatures has forced astronomers worldwide to seriously reconsider fundamental assumptions about how interstellar objects behave when passing through alien star systems, opening entirely new avenues of research into the complex dynamics governing these mysterious cosmic wanderers. Patterns in the void. The intrigue deepened when the Vera C. Rubin Observatory Analysis Group, led by Dr. Zdenka Vokrulicki, noted a trend in the frequency of interstellar objects visiting our solar system. Since the surprise of Oumuamua in October 2017 and 2I/Borisov in December 2019, detection rates have steadily increased, thanks to improved survey technology and, better international coordination. The International Astronomical Union actually convened a special panel to discuss the implications for galactic object exchange, stressing that the regular arrival of such bodies really challenges previous models of solar system isolation. Each confirmed object, now that's 3 in under a decade, forces a rewriting of our assumptions about material drifting between stars and the dynamic nature of our galactic neighborhood. Statistical analysis suggests that thousands of similar objects pass through the outer solar system undetected each year, representing a vast population of interstellar wanderers. The pattern indicates that our solar system sits within a stream of cosmic debris ejected from stellar systems throughout the Milky Way galaxy. And advanced detection capabilities promise to reveal many more such visitors, fundamentally changing our understanding of how matter moves between star systems and the frequency of interstellar exchanges. The machine hypothesis. New web imagery processed by the Space Telescope Science Institute in Baltimore and interpreted by a multidisciplinary panel led in part by Dr. Avi Loeb, set off debate on possible artificial origins. Loeb highlighted unexpected geometry in the object right-angle reflectivity patterns and non-random surface features that seemed inconsistent with natural formation processes. The European Space Agency's JWST spectroscopy division found thermally anomalous regions and odd shadowing that defied conventional models of cometary behavior. Team member Dr. Heidi Hamel, planetary scientist and JWST co-investigator, cautioned that such findings don't yet confirm technology, but the conversation around the machine hypothesis went global after unexpected press releases. The object's surface appeared remarkably smooth and uniform, lacking the irregular features typical of natural space debris that's been battered by cosmic rays and micrometeorites during interstellar travel. Advanced imaging revealed geometric patterns that some researchers interpreted as possible structural elements, though others argued these could result from unusual crystallization processes during the object's formation. The debate really highlighted the challenges of distinguishing between natural and artificial characteristics when examining objects from unknown stellar environments with, potentially different formation conditions. Spectral secrets. Spectroscopic data from the James Webb NIRSpec instrument showed 3I/Atlas contains unfamiliar mixtures of organics, silicates, and metallic alloys, not typical for solar system comets. Dr. Alan Fitzsimmons from Queen's University Belfast identified a significant absorption at 1.5 microns, associated with hydrated minerals, alongside anomalous emission lines unexplained by water or carbon dioxide alone. NASA's Goddard Space Flight Center provided confirmation, reporting faint but consistent microwave emissions that suggested active internal processes. Dr. Jessica Agarwal from the German Aerospace Center noted these combined features could suggest prior irradiation or artificial alteration of native ices, fueling both natural and technological hypotheses about the object's origin. The spectral signatures revealed isotopic ratios that differed from typical solar system materials, indicating formation in an environment with different stellar nucleosynthesis products. Rare Earth elements appeared in concentrations that challenged existing models of planetary formation and cometary composition. And the presence of complex organic molecules typically associated with biological processes sparked additional speculation, though researchers emphasized that such compounds can form through natural chemical processes in interstellar space. The information blackout. So, amid mounting discoveries, global scientists started to notice restricted access to JWST raw data beginning on August 18, 2025. Dr. Joseph Maciero of the Planetary Defense Coordination Office testified that agency data review protocols were now being applied to 3I/Atlas, and he cited national security as the reason for limiting information sharing. Meanwhile, SETI Institute researchers, led by Dr. Jill Tarter, raised open letters demanding transparency, and the European Space Agency's Gaia mission team quietly shared independent astrometry with their international colleagues. Tensions really flared during an American Astronomical Society session, when international collaboration took a back seat to agency security reviews. This just revealed the growing friction between open science and government oversight on cosmic anomalies. Scientists expressed a lot of frustration that crucial observation windows were being compromised by bureaucratic delays and, honestly, classification concerns. The controversy really highlighted some fundamental questions about who controls access to cosmic discoveries and whether potential extraterrestrial contact should be subject to governmental secrecy. In response, international researchers began developing independent observation networks to ensure that scientific data would remain accessible to the global community, regardless of individual government policies regarding space-based discoveries and their potential implications for national security. Controlled heat and hidden intent. Thermal mapping using Webb MIRI instruments, supervised by Dr. Michael Werner at JPL, exhibited these adaptive temperature zones across the object's surface, which honestly is not something you see in typical comets. Dr. Christina Thomas at Northern Arizona University presented findings of synchronous heat regulation, and that really stands out, especially when you compare it to the chaotic surface cooling we've seen on icy nuclei, like 67P Churyumov-Gerasimenko. Now, key data obtained near perihelion on August 19, 2025, revealed the stabilization of energy emission regions that actually seem to respond intelligently to solar heating. Theorist Dr. Gregory Laughlin at Yale even hypothesized that such signatures might imply, quote, thermal shielding or technology for intent-driven adaptation, a radical but now openly discussed possibility among planetary scientists. The temperature control followed these predictable patterns that maintained optimal conditions for preserving internal structures, and that honestly suggests either remarkable natural adaptation or deliberate engineering. Computer models showed that natural processes alone just couldn't account for the precision of thermal regulation observed across different surface regions. What's even more surprising is that the controlled heating patterns persisted, even as the object moved through varying solar radiation intensities, indicating active, rather than passive, thermal management systems that really defy our conventional understanding of cometary physics. The prime number message. Analysis teams at the Max Planck Institute for Radio Astronomy, led by Dr. Michael Kramer, detected heat emission modulations that, after Fourier transformation, revealed repeated prime number sequences embedded in the thermal output. Dr. Sophia Sheikh, a SETI researcher, independently validated a 17-23-31 pattern in night-to-night thermal variations using Green Bank Observatory data and, well, some pretty sophisticated signal processing techniques. This prime encoding is considered by scientists, as originally argued by Carl Sagan, to be the most likely signal structure used by non-human intelligences trying to communicate across interstellar distances. The findings, if verified by international SETI groups, could actually represent the first candidate evidence for information intentionally encoded in a celestial object passing through our solar system. The mathematical sequences appeared with statistical significance far exceeding random thermal fluctuations, suggesting deliberate modulation of heat emission patterns. Multiple independent verification attempts confirmed those prime number sequences across different observation periods and wavelengths. The discovery prompted emergency sessions at SETI institutes worldwide, as researchers grappled with the possibility that, just maybe, humanity had detected its first confirmed extraterrestrial communication attempt, though, of course, skeptics continued to search for natural explanations. The Watchers and the Watched. With the International Astronomical Union's special session, the world watched as experts like Dr. Lisa Kaltenegger from Cornell, astrobiologist Dr. Sarah Seeger, Planetary Protection Officer Dr. Catherine Conley, and SETI pioneer Frank Drake reflected on the profound implications of these discoveries. The paradigm has fundamentally shifted. The idea that humanity is the primary watcher of the cosmos has, well, inverted, with 3i Atlas representing potential evidence that we ourselves are being observed and studied. This reversal sparks some really intense debate about whether ethical and existential responsibilities should ever be confirmed, especially with direct, possibly intentional signatures detected in a passing interstellar visitor. The story of 3i Atlas will shape cosmic policy, philosophy, and planetary science for decades to come as humanity grapples with its changing role in the universe. Scientists are now developing new protocols for handling potential extraterrestrial contact scenarios, recognizing that traditional assumptions about human cosmic isolation may no longer apply. The discovery has prompted philosophical discussions about humanity's readiness for contact with advanced civilizations and the implications of being observed by intelligence that may have been studying Earth for extended periods. International cooperation frameworks are being established to ensure unified responses to future encounters with potentially artificial interstellar objects. The first real image from the James Webb Space Telescope begins a bold chapter in cosmic history. As data pours in and global teams compete and cooperate across boundaries, 3I Atlas stands as both a scientific puzzle and a reminder of our shared curiosity about the universe. The search for answers continues to accelerate with each new discovery. Keep exploring the cosmos with Simply Science. Like, share, and subscribe for our next cosmic revelation.